Hello, here's a question that looks like it's going to be fairly straightforward. You've got to solve 3 cos x minus 4 sine x equals 2. And on first glance, you'd think you could just rearrange this, get tan x, but you might just want to pause the video for a minute, see if you can work this out, how you would rearrange to solve this equation. You'll probably find that it's very difficult to rearrange this. It's not an easy equation to solve at all. So to put you out of your misery, if you're struggling, the way to do this is to think about what the graph would look like for the left-hand side. If you were to sketch y equals that, what would the graph look like? I just sketched the graph on autograph here, and you can see that the left hand side here is the red graph down below. And if you compare the graph of this, which is the red graph, to the graph of y equals cos x, which is the blue dotted graph, you can see it's very similar. So this graph is the cos graph, but it's just been stretched in the y direction, and it's been translated to the left in the negative x direction. So because of that, the left-hand side of this equation can be written like this, because as I say, this will be the stretch in the y direction, and this will make it translate left. Now if we look at the graph, if we look at how we've gone from the cos graph to the graph of 3 cos x minus 4 sine x, if we just pick a point here, that point has ended up over here. Now it's gone from y equals 1 to y equals 5, so that would suggest that r equals 5 here. In the same way, this has gone from -1 down to -5. So it suggests that r equals 5. And to find this value here, you need to have a look how far has this point moved to the left, and it's very difficult to tell, but that would be 45 degrees, and so it looks like it's going to be over 45, roughly around about 50. So for a guess, I'd say alpha here is going to be roughly 50 degrees, but that's not very mathematical, so we need a proper way of finding out what r and alpha would be. Now the whole point of doing this is because if we can write this equation, the left hand side of this equation here, as this, then it's easy to solve now. We just divide by whatever r is, do inverse cos, and solve as normal. Okay, so the equation we had up here, which we couldn't solve by rearranging, we'll now be able to solve it by getting it into the form r cos x plus alpha. So how do we write 3 cos x minus 4 sine x in the form r cos x plus alpha? Well, we can just use the addition formulas. So if we start with cos x plus alpha, remember what we're trying to do here, actually I'll just get rid of that. What we're trying to do here is just work out what r is. Remember, we suspect that r is going to be 5, and then we want to work out what alpha is, and we suspect that's approximately 50, but we need to work this out exact. So if we do the addition formula for cos, that's going to be cos x cos alpha minus sine x sine alpha. Now don't forget there's actually an r in the front here, so when we multiply the right hand side by r, there'll be an r here and an r here as well. So that's just using the addition formula for cos a plus b. Now if we compare that with what we've got here, if we compare that with this, this equals, I'll just write it down here, that equals 3 cos x minus 4 sine x. So if we compare this row with the row above it, we've got cos x here and cos x here, and so r cos alpha must equal that 3. Remember these two lines here and here, they must be equivalent because they both equal this. So if this is cos x here and this is cos x here, then the r cos alpha must equal 3. So let's write that down. R cos alpha must equal 3. And in a similar way, if we've got sine x here and sine x here, then r sine alpha must equal 4. And we don't need to put a minus because the minus is already accounted for here. So we can ignore the minus. In fact, you should never get a negative sign when you get to this stage for these questions. If you do, then you've done something wrong. So we've got this, r sine alpha equals 4, r cos alpha equals 3. We just want to solve these two simultaneous equations now to work out what r and alpha would be. Quickest way is probably just to, there's lots of ways of doing it. The quickest way is probably just to divide these two. So if we divide, oh, sorry about that, it's gone. It's back. So if we divide them, the r's will cancel, and sine alpha over cos theta will give us tan alpha equals 4 over 3. And then we just do inverse tan on our calculators, and that will give us 53.1. So we suspected over here that alpha was going to be about 50, and it turns out it's 53.1 to 1 decimal place. How do we work out what r is? Well, you could just substitute what alpha is back into the well, either of these two if you liked, but the easiest way is to use the fact that r squared is always this squared plus this squared, and the reason for that is if you were to do the top row all squared, you'd get r squared sine squared alpha. Add that to the bottom row, r squared cos squared alpha, and that would equal 4 squared plus 3 squared, and this would factorize to give you sine squared alpha plus cos squared alpha. This all equals 1, as you know. So then r squared is 4 squared plus 3 squared, as I wrote above. Now you don't need to worry about this. You certainly don't need to write that down every single time, but that's the reason this works. Another way of thinking about this is just the same as having a right angle triangle would look like this. This is 4, this is 3, this is 53.1, and this is 5 using Pythagoras. So whichever way you do this, you're going to end up with r equals 5, which is what we said at the top from looking at the graph. So to write, if the question says write this in the form r cos x plus alpha, then the answer is 5 cos x plus 53.1 degrees. Now remember, the actual question was to solve this equal to 2. So if we want to now solve this, the highlighted equation there equal to 2, then it's the same as solving this 5 cos x plus 53.1 equal to 2, and that's quite easy to solve now. We just divide by 5, do inverse cos and solve the way we normally solve these. So cos x plus 53.1 equals 2/5, and if we do inverse cos both sides, we'll get 66.4 degrees. Doing this all to one decimal place. Now don't subtract 53.1. I'm sure you've done lots of these before, but don't subtract the 53.1 till the very end. We've got to find the other values. I use the cast diagram. So 66.4 degrees. Cos is positive, it's plus 2/5, so it's going to be here and here. So we've got 66.4 degrees. So where else do we want a value? Well, it would be this one. So that's 360 minus 66.4. So that will give us another value of 293.6 degrees. And I think those are the only two values in the range. I'm not sure if it actually told us our range in the question. I think it was 0 to 360, in which case we just subtract 53.1 now, and that will be the two answers to the question. Here's a very similar question to the one we've just done. Just this time it's our sine x plus alpha rather than cos. You might just want to pause the video now, try and do it yourself, and then check this solution in a minute. So we want to do similar to what we did above. We want to express the left hand side of this in the form r sine x plus alpha. So we want to do the let's just forget about the alpha for a minute. So if we do the addition formula for sine this time, that's going to give us sine x cos alpha plus cos x sine alpha. Don't forget there's an r in front, so multiply everything by r. And then the left hand side of this here is 5 sine x plus 12 cos x. So sine x and sine x there, so that means r cos alpha equals 5. Write that down, r cos alpha equals 5. In a similar way, we've got r sine alpha equals 12. And then divide to get tan alpha is 12 over 5. Do inverse tan, and you should get 67.4 for alpha. To find r, you do r squared is 12 squared plus 5 squared, so r is going to equal 13. So that means the left hand side of the equation can be written 13 sine x plus 67.4 degrees. If we now want to solve this equal to 2, as the question says, we can then divide by 13, do inverse sine of 2 over 13. That will give 8.85. I got 171.5. Sorry, 115 and 368.85. That's from using the cast diagram. And so if we subtract 67.4 from all of those, actually this one won't give us a value in a range. I got 103.75 and 301.45 for the answers to those. Remember, these were found using the cast diagram, or whichever method you usually find to solve equations like this.